Well, welcome back to these segments of stories shared on behalf of National Dairy Shrine, highlighting some of those who have made incredible impacts and influences on the dairy industry. I'm Peggy Coffeen from the Uplevel Dairy Podcast, and it's my pleasure to sit next to Dr. George Wiggans. Welcome.
Thank you.
And now, George, you worked for many years alongside Dr. Paul Van Radden and really created this unparalleled impact in the world of dairy cattle genetics, genomic evaluations, and developed what is the systems that we use today that are driving the dairy industry forward and doubled genetic progress in North America. And so let's get to know you a little bit. How did you get your start, George?
Well, similar to Dr. Van Radden, I grew up on a dairy farm. My parents' farm was in upstate New York. Actually, our address was Aurora, which is right on Keoga Lake. And so I had that experience growing up on a dairy farm, which is actually useful in my profession, in that I sort of knew what things are like on the ground.
Yeah, and so you grew up on the dairy farm. You knew the nuts and bolts and the hard work that it took to be in the industry at that time, which was a pretty labor-intense industry in those days, huh?
Right, yes. Getting up to milk the cows, right?
Yeah, so what was it about that led you to the interest in genetics particularly?
Well, that's another nice story. Part of this whole issue of career is the people that mentored you. So, to start out, my grandfather was a professor at Cornell in plant breeding. So there was always, in addition to the dairy farm, we had a hybrid seed business where we had the male plants fertilizing the female plants, remove the tassels from the ones that are supposed to just get the pollen from the male. So, it was an environment that wasn't foreign to me. But then the sort of mentoring thing was that my whole life, with my grandfather as a professor, both my parents as Cornell graduates, it was sort of taken for granted that I would go to Cornell. But so I was accepted in the ag school, and I had an advisor. And the advisors were also a little concerned about children from rural schools, how they would handle in these courses that have all of these sort of brilliant children from New York City as competitors. So when I did fairly well in calculus, he said, I have somebody I want you to talk to. So that was Dr. Willem van Vleck, who was the professor of animal breeding, and he said, we think that with your background in dairy and your interest and ability and numeracy, if you will, that this would be a good area for you to work in. Sounded good to me. And then sort of the icing on the cake was that working with genetics is really a great deal of managing data and trying to extract the genetic component out of what we observe in the field. So this means that you use computers. You write computer programs. Computer programs are something where you can do something, you can run it, and you find out immediately whether you're successful or not, and you can go back and fix it. You don't have huge expenses of what you wasted when you got it wrong. You can fix it immediately and go on. So I was hooked.
So there was that light bulb that went on for you when there was this intersection between your skill sets and your background and the opportunity that computer program could bring into that, and it opened up this whole new world.
Right.
Yeah, and so paint the picture for me when you think about the world of dairy cattle genetics at that point in time. How would you describe it looking back?
Well, another aspect of Cornell was that Cornell had a leading department of genetics. Dr. Charles Henderson was kind of the father of modern animal breeding. So to be in that environment and have him, he lived just a few houses away from my grandfather's house and been in Forest Home, New York. So there was that connection. But at that point, as an undergraduate, I was convinced that I could stay and get a master's degree by taking courses that would lead to the master's degree in 1 year. But at that time I wasn't thinking that I'd just stay on and get a PhD. I had an interest in international agriculture, partly from the point of view of, at that time we saw the U.S. as being a surplus producer of food, so it seemed like the real need was to extend our technology internationally, and so I could saw myself as being working in international agriculture. So by that time I was either married or about to get married. So my wife and I wanted to be Peace Corps volunteers, but her health condition didn't permit her to do that. So we ended up with the International Voluntary Service and spent over 2 years in Laos working agricultural development. So that I didn't directly answer your question, but that was sort of the tangent that. And so of course, it isn't quite what you expect. You think, oh, the great technology will share it with the unwashed, so to speak, and everything will be great. In Laos, there was the Vietnam War kind of spilled over in that area. So at the time we started, several volunteers had been assassinated, and we were restricted to staying in the provincial centers. So, but the opportunity to see the world, to travel, to have some training in the Philippines. So we saw the Rice Research Institute there. So my life has just been fortunate in the opportunities and exposure and people I've met all over the world. So I skipped your question really, but we could go ahead.
But you actually went down an interesting path here of sharing that, what led you to that international experience. And it sounds like that was an area that really spoke to you, was how to help those developing parts of the world and feeding the world, huh?
Yeah, well, I mean, another way of looking at it, okay, how do you want to spend your life? So the appeal of taking over the family farm and being a producer, if there was already a surplus, is this really, is this what I want to do? I mean, is this an important contribution? So that was kind of a negative side of it. On our farm, we'd been involved with Cornell in that they had a farm practice requirement. So people who did not come from farms would need to work a certain amount of time on a farm so they knew something about agriculture. So we had that international exposure basically the whole time I was growing up. So the idea of foreign countries weren't scary. That was so. But I mean, I guess the main motivation is this is a place where the skills that I have should be useful and valuable.
And so when you looked at those skill sets, they eventually brought you back to dairy cattle.
Yeah. Well, okay, so we spent time in Laos. But I didn't see joining the Foreign Agriculture Service, for instance, and making a career of living abroad. I saw the benefit of moving back to the U.S. My sister and her husband were working at a kind of a school for emotionally disturbed children, which had a model farm. So they had horses and cows and sheep and goats. And so they said, "Why don't you come work with us?" So that was my exposure to goats, but it's also my exposure to children that were difficult to manage. And there was a limited lifetime of that is what I wanted to do. So that convinced me that Cornell was willing to take me in a PhD program, even though I'd done my undergraduate work there, but having a break and it's a chance to see the world in between, they accepted me. So that's how basically I got started in what turned out to be my career.
Wow, and so you ended up spending a long part of your career with the USDA.
Right.
Was that your next step after getting your PhD,
yes.
Or was there something else in between?
Right. You have to find a job when you get a PhD, so I interviewed. They wanted to hire me. I actually did a short postdoc at Cornell because getting hired by the U.S. government is not all that simple, so it was nice to have it occur at a certain time point. And then the fact that I had worked on this model farm gave me some knowledge of goats, and one of my projects was to extend the techniques we used for dairy cattle evaluation to goats, so we could have evaluations for dairy goats. So that was, I was the goat guy initially.
Oh, so you were diverse in your in your dairy related genetics,
right.
And so let's just touch on your time with USDA. Was it always a genetics focus there for you?
Yeah, so it was initially the Animal Improvement Programs Laboratory, and we had the sort of operational responsibility for calculating the evaluations. So it was at that point twice a year that we had to collate all the data and run it through the system, and as an ongoing basis, we had to deal with sort of data quality issues and interacting with suppliers. And then with the research, as we added new features, basically new traits, when I started, it's only recently that an analysis for protein was available through the new analyzing equipment. So then protein was added as another trait in the evaluation. And then, there's a progression of traits that were added because the whole goal is to identify the animals will be most productive. So that productivity is not just how much milk they give, but what the components are, how robust they are, all the modern things you think about it, longevity. So a lot of that was interacting with the dairy record processing centers, and one project was to improve the estimates of the lactation yield based on just a few test days. So the test day model was where we recognized that the last piece of information we have was probably the most useful estimate in what was going to happen in the rest of lactation than just the average of all the data. And one of the projects that Paul Van Radden worked on was actually extending that to say, let's see how much each individual test that we have tells us about the lactation total. So a way of sort of mathematical modeling, taking into account the relationship between each test day and the total yield, and making a prediction based on that. But genomics sort of overwhelmed everything else we did because it had such a transformative effect on the work.
Yeah, so genomics, you just said that word. So
right.
At what point in your tenure with USDA did genomics become an integral part of the conversation? What era did that come up for you in your work?
It sort of tracks the whole aspect of DNA analysis. The human genome was determined, and then that meant that people willing to make the investment, we could do it for cows. Then, given that this work, we can try to have a profile that will enable us to predict the cow's productivity. So, I was in some sense a bystander or a beneficiary of a lot of the initial work where they came up with low-cost ways to come up with a genomic profile. Cook Van Tassel was a leader in that part of the work where they came up with what we call a chip. It looks like a microscope slide that had 50,000 markers on it, and it turned out to be an inspired choice of markers because they sufficiently represented the entire genome of the cattle that we could come up with good estimates of their productivity based on those 50 sort of yes or no, or I got this allele versus that allele genomic information.
So for you, as a person that worked in the numbers, understood cows, and saw this bigger picture, was this idea of genomics and using that science, was it something that made sense to you right away, or did it take a little time for you to believe in it?
Yeah, I see the point of your question, but really sort of hate to admit that the cows weren't as important as the numbers. So they represent these traits. So it's easy to understand how genomics. One of the things that was really exciting about this was that we could say some things with certainty. This bull is the father of this cow because the genomic profiles demonstrate that. It's not a question of did the person who observed the birth get the calves mixed up. So that putting us in a position of having things that we could sort of completely rely on. Now, of course, it's everything's an estimate or prediction of the future, but having aspects of the data that we could really rely on, and then could be the basis of further discoveries. You know, it's like it's this reservoir of information. We keep clawing away to learn more about it, and some of the things just arise naturally. Like I said, well, we can really be certain this is the sire of this cow, or this is not the sire. So we'd say, no, sorry, there's too many conflicts. This couldn't be. And they say, well, we did a previous microsatellite-based analysis. It's a DNA-based thing, but it's more expensive, and and it only had a few markers. So how could this be? So then we look at it, we notice that all of the conflicts that we were complaining about that said it has more than what you would expect from a true parent-progeny relationship are on the same chromosome, in the same area. If we had a deletion or some sort of chromosomal abnormality, it would explain that. Aha! So then we could add to our system, searching for that kind of condition, and if that was found, then we'd say, previously we would have said, you got the wrong sire here. Now we could say, it's the correct sire with this chromosomal abnormality. It's a little bit related to what we were calling haplotypes affecting fertility, and it's a similar kind of thing. Actually it turns out to be a little bit more complicated, but it's like the calves that never showed up, because we would break the entire genome up into these chunks, and then we would store all those, and then we could compare, and we say we never seem to get another animal in our system that has the same this haplotype from both parents. So then we would look at the fertility, and we say, with this sire-maternal grandsire combination, do we have a lower fertility rate? Like a connection between those two. So then, you go in, and people who are experts in the biometrics, analyzing the genome, could find a defect. So we could narrow it down. Okay, this is like we have a fair number of these defects. We've now found the actual place in the chromosome based on what we call full sequence data, where we try to get the alleles that are present at each place. The parts of the genome that there's no change in, we're not interested in. So it's only where some have what we'll call the A allele and some have the B allele. So that's where the information is.
So what started out as being able to really identify parentage developed into the ability to find these haplotypes,
right,
and to continue to look at ways to really fine-tune and hone in on what was possible by having that accurate genetic information, and then empowering the choices that could be made around it. And this all, realistically, George, this happened in short order. When you look at the last decade or so of the advent and acceptance and fast tracking of genetics through genomics, this is all represents change, right?
Right.
So talk about change.
Yeah, that's. I'd like to tie in, going back to my interest in international agriculture. And in the training, of course, there was a lot of discussion about how do you convince people to accept new things. They talk about traditional culture, and this is their kind of way of life thing. So, that was always a concern that maybe you just say, oh, for those farmers are conservative, they don't want to change anything. Of course, you could say their livelihood depends on the success of their cattle and their crops. So, of course, they're a little hesitant about taking big risks. So then we move into genomics, and we would chart what proportion of the cows are bred to bulls that at the time of the insemination, they had no milking daughters. These are bulls that the only information they have on these is what we told them based on this genomic profile. And you'd say that just going up year by year, and more to the point now where there's most of the cows are bred to these genomic bulls because the rate of genetic improvement is so fast that by the time they get milking daughters, there's another generation of superior genomic bulls to use. So it could be, initially people were hesitant. They built a reputation on their methods that they use for bull selection, and how the daughter, they'd want to list the daughters, they'd do daughter inspection, and for us to say, forget all that, we've got a different answer. But they look around and see what everybody else is doing. If they want to be competitive, they had to achieve the same rate of genetic gain that others were doing. So, do I say, when you have a good enough product, the acceptance is almost automatic, or if you force people, because they have no choice, they'll do what they have to do.
But this technology proved itself.
Yes.
It proved itself on paper, on the numbers, and now we have generations of cattle that prove themselves in the barn with their production, their performance, their longevity, their health.
Right. Yeah. Right. Of course, we doing the math would say that why should that be a surprise? The only way we're able to say anything is by looking at cows in the past. What was their genetic profile? Basically, which were the segments of the chromosome that were associated with higher production, and then the future animals that had those segments, we're going to predict those to be more productive. And sure enough, they are.
There you go.
No, I mean, anything could fail, but I'm saying that what we did was based on past performance.
Yeah, past performance, but becoming a strong indicator of future.
Yeah.
Right? And so when you think about the impact of that work, what brings you the most satisfaction?
Well, getting into kind of on the job, anything that you do where you see that it has an impact, a positive impact, is satisfying. And working with the industry where we get a chance to attend meetings and talk to people and see how it all works, it's nice to feel that you've been a part of that success. So I'd say that nothing breeds well, success is a good support for happiness, as you might say.
And again, when we look at all of these different aspects of success as a result of really having the instinct and determination to drive change. Yeah. One of the areas that you've also been front and center for were these daughter-driven proofs for the genomic evaluations. So talk about that change.
Of course, basically the only way we can make a prediction is if we have cows that actually gave milk and analyzed the fat and protein, had the health records. So as you say, daughter-driven, of course, the daughters were where the data came from. So maybe your question was that now you could say that we don't wait for the bull to have daughters, we can evaluate him just based on his DNA. Mm-hmm. And the fact that people were willing to accept that, and maybe that's kind of the point of the credibility of the process was such that was something people could accept. And I guess that's your point, that if you wait for the daughter-based evaluation, the bull's 5 years old, and his competition are bulls that are 1 year old based on the genomics, and they've had the benefit. When you think about how all this works, the only way you make progress is by having is when you create a new generation. So we can say, oh, genomics made us double the rate of genetic improvement. Genomics made us be able to have the generation interval so that the rate of genetic. So you could say, well, we're pretty much making the same improvement per generation we always were. It's just we have twice as many generations.
Oh, and you know, when you think about just the way that things have evolved, how quickly that progress has been made, what's next? What do you think the future looks like of where the growth and gains can continue? And what are you most excited to watch unfold in this area of genetics and genomics and progress?
Right. Well, the thread of an interview like this makes one realize that this is a good thing to think about. So just today I was trying to learn a little bit more about at what age can you collect ova from a young female calf. So currently you can more or less reliably get them at 9 to 10 months. It's possible to, with significant effort, to get it much younger. Will that process for the very elite become more and more common? Because if you reduce the generation interval by 6 months, that's 6 months. Because an aspect of your question is, what is it that we can do? Probably the more immediate things are that we can collect more traits or get more information to make existing traits more accurate, so that we better measure the economic impact of a cow's genetics in the first place. So the recent work on feed efficiency and the prospect of getting more feed efficiency data is something like that. Now, everyone talks about how will artificial intelligence affect the industry, and probably everybody you ask has a slightly different aspect on that. But the idea that with more sensors, we collect more data. With more data, we can make better decisions, and as we have more data, we can make genetic evaluations more accurate in predicting basically the contribution of the cow. It seems like it was earlier in my career, there was always the worry about selection limits, that how much milk can a cow actually ever give physically. Nobody seems to talk about that anymore. It seems like we just keep making herd averages of 25 or 30,000 pounds. No big deal.
And now that's average, right? Now that's an average. Yeah.
So I have no real insight as to whether there's the future is just more of the continued trends, but I think we realize there's benefit investing in our data, in the technologies. We don't want to say we're satisfied with where we are. We want to say we have a history of being exploiters of science, and we want to continue to do so.
Well, in that attitude and that spirit of using science in the pursuit of progress and improvement has led you to where you are today, and that's someone who's had an incredible impact on the advancement of dairy cattle genetics here in the U.S. and beyond. And in fact, it led you this year to be recognized as one of National Dairy Shrine's Pioneer Award winners. So first, congratulations, George. What did that award mean to you?
Well, I think we're all very pleased that when something we're been involved in is successful, and to have that kind of recognition. You can often say people don't really understand how important what we've been doing is, and to have this widespread recognition of our work is very satisfying. It's very important that I make it clear that I have been a beneficiary of working with a team that's been highly productive and a pleasure to work with. One aspect of the teams, both the USDA and more recently with the Council, is a long longevity. People have been happy in their work, also feeling that they're making contribution, and stayed with us for a long time, and further enabling us to be successful.
So that definition of meaning for you has a lot to do with meaningful work that not only has had an outward effect, but that you can see it with the team that you work side by side with to deliver what we see today in progress and advancements. Anything else you'd like to add today, George?
No, I think we've sung our song of industry praise adequately for this session.
Well, thank you for joining me and sitting down to have this conversation with Dr. George Wiggans. And again, congratulations on your recent honor as a Pioneer Award winner for the National Dairy Shrine. And we thank you for sharing your stories and allowing us to capture your experiences and your voice for this series of collections of history for National Dairy Shrine. I'm Peggy Coffeen from Uplevel Dairy Podcast, and thanks for joining us for this conversation with award winner, Dr. George Wiggans.
Thank you.